Our final topic under the heading of trigonometric graphs is parametric equations. Our objective here, given graph parametric equations, including, I think it's pronounced Lissajous, but that's probably someone in France would probably want to correct me on that, including Lissajous figures, and we're going to do this using Desmos. Well, first off, what is a parametric equation? Well, a parametric equation is a set of functions, a set of equations linked by one or more independent variables. An example, x is equal to the cosine of t and y is equal to the sine of t. So I have two equations. One equation gives me the x coordinate, one equation gives me the y coordinate, and they are linked by this variable t, as you see here. Parametric equations are very useful for defining curves, surfaces, etc. Often, and this is kind of the way I look at it, often the variable t stands for time, which then dictates the location, the x and the y, of an object over a period of time. So at time, let's say 0 seconds, the object is here. At time 1 second, the object moves to here. At time 2 seconds, the object moves to here. So the x and y give us a point, and t equals 0, 1, 2, 3 tell us where that point is located. For example, at time 0 seconds, 1 second, 2 seconds, 2 seconds, etc. In Desmos, to graph parametric equations, it's really quite simple. We're going to type the x and y expressions as a point, and we're going to use the letter t and set the parameters for t as applicable to the problem. Let's take a look at a couple. Okay, this first one, graph the parametric equations x is equal to 4 minus t and y is equal to t squared. So I'm going to have the t values go from 0 to 3. And again, you might want to think of this as seconds. At time 0 seconds, where am I located? 1 second, 2, 3. Okay, let's find the point. At time 0 seconds, 4 minus 0 is 4. The x coordinate is 4. At time 0 seconds, 0 squared is 0. The y coordinate is 0. So go to the graph. 1, 2, 3, 4. Okay, at time 0, I'm at the point 4, 0. And I'll put a little t equals 0 here. I'm at the point 4, 0. Okay, where am I at time 1? When t equals 1, 4 minus 1 is 3. That's the x coordinate. When t equals 1, 1 squared is 1. The y coordinate is 1. So I am at 3, 1 here when the t equals 1. And again, you can think of this as seconds. At 1 second, I've moved from here to here. Okay, where am I at t equals 2? Well, the x coordinate is going to be 4 minus 2, which is 2. The y coordinate is going to be 2 squared, which is 4. Okay, so I'm at the point 2, 4. 1, 2, 3, 4. 2, 4 is approximately here. And here's where I am when t is equal to 2. And finally, where am I when t is equal to 3? Well, 4 minus 3 is 1. The x-coordinate is 1. And 3 squared is 9. The y-coordinate is 9. So when t equals 3, I'm at the point 1, 9. If that's 4, 5, 6, 7, 8. Oh, I got close. I missed a little bit, but we'll go up to there. Whoops, and I got to find the 1. So I didn't make my tick marks fit on my graph. Oh, that's okay. We make it work. And there's time t equals 3. So you can see what's going on here as we connect these points. We're kind of creating an exponential type thing. And of course, I could have done t equals a half, t equals 1.1, and I would be in here as we move up. I just did that. Okay, so there's our graph. Let's take a look at that using Desmos and how it works. Okay, I get Desmos in here. and hopefully get it straightened out. Okay, so what we want to do here, we want to create our x and y's as a point. So I'm going to use parentheses. Okay, the x coordinate was 4 minus t. 4 minus ABC t. And Desmos seems to like t using for parametric equations. So there's the x coordinate. Now go back in here and type a comma. That's the x coordinate. Now I need the y coordinate. Well, the y coordinate was t squared. So I'll go back in here and choose the t. And I'll go back over to here and I'll choose squared. Okay, and then I will close the parentheses. There's the point. The x coordinate is 4 minus t. The y coordinate is t squared. And you'll see that Desmos is now looking for the parameters of t. Where do you want t to go from and then to? And it defaults to 1. Well, there we are. There's our, I think I can't. I learned that earlier. You can't tap on this to find the points, unfortunately, in parametric equations. Well, we went from t equals 1 to t equals 3. There you go. So we started here. When t equals 0, we were at the point 0,4. When t was 1, we were at the point 3,1. And again, unfortunately, you can't tap it and have it come up. It doesn't do that. And the graph went this way. If we wanted to go further with t equals 5. Well, obviously now we're going up to here. Okay, when t was 5, we're at the point -1, 25. So that's how parametric equations work in Desmos. Let's take a look at an example that uses sines and cosines. Give me a moment. Because this is where the Lissajous, man, I seriously cannot pronounce that. This is where we're going to see this Lissajous figure come into play. Okay, what is a Lissajous figure? It's a graph of parametric equations that involve the trig functions. Okay, so now we're going to pull in the trig functions and see what we get. So our example 2 here, use Desmos to display the Lissajous figure defined by these two parametric equations. The x coordinate is equal to 2 times the sine of pi t, and the y coordinate is equal to the cosine of t. Okay, so again we've got two equations that are connected by a variable, in this case t. Okay, I went ahead. I just basically did the first quadrant. I went from 0 to pi over 6 to pi over 4 to pi over 3 to pi over 2, just to put in the numbers for that. Not that it really can make a difference, but we'll just see the numbers. So when t is 0, x equals 2 times the sine of 0, which is 0, and the y coordinate is equal to the cosine of 0, which is 1. So at time 0, we're going to start at the point 0, 1. When we go to pi over 6, and I rounded these to the tenths, the x coordinate is approximately 2. The y coordinate is approximately 9/10. When we go to t is equal to pi over 4, the x coordinate is approximately 1.2. The y coordinate is approximately 0.7. Pi over 3, the x coordinate goes negative, 0.3. The y coordinate stays positive at 0.5. And at pi over 2, the x coordinate is approximately -2, and the y coordinate is 0. So I just put those numbers into a table so you can see them, and I round them to the nearest tenth. Okay, so now before we take a look at this on Desmos, let's determine how far we want our t's to go. Okay, what should our t parameters be? Well, let's first notice the period of the first equation, the x equation, 2 times the sine of pi times t. Okay, let's find out what this period is. We know that our period is equal to 2 pi over b, and b in this case is pi. So it's 2 pi over pi, and that of course is 2. So the x equation has a period of 2. They don't begin repeating itself. Let's take a look at the y equation. What is the period of the y equation, which is the cosine of t? And we already know this. The period of cosine is 2 pi. We can do it mathematically if we want. 2 pi over b. b is 1. It's 2 pi over 1, which is 2 pi. But we knew that. The period of the cosine function is 2 pi. Now notice 2 pi is greater than 2. Pi is approximately 3. 2 times 3 is 6. So we want to note that 2 pi is greater than 2. And we want to use the larger of the two to define our function. So we make sure we get an entire period in there. So we have to go to 2 pi. That'll have this one repeat itself a couple of times, but that's okay. We want to make sure we complete a full period of both. And the only way we complete a full period of both is if we go 2 pi units. So 2 pi is larger than 2. So we'll use 2 pi, which is the longer period, to dictate t values. In other words, we'll have our t go from 0 to 2 pi when we put this into Desmos. Let's take a peek. Lissajous figures are kind of neat to see. They're very curvy, and they can make unique shapes. We're just doing one example here, and let me get back on here. Okay, so I'll delete the one we did previously. So now, what's our point? Well, we put a point in with a parenthesis. The x-coordinate is 2 times the sine. I'll go to functions and find sine of pi, which is down here at the bottom left, times t. Where's my t? There it is. Okay, I'll close that. I'll close up the what the sine is what we're taking the sine of. I'll put a comma in there. And the y-coordinate is the cosine of t, so cosine. And then find my t. And then I'll close up both parentheses. So the x-coordinate, 2 sine pi t, comma, the y-coordinate, cosine of t. And you can see it simply drew from 0 to 1. Well, we want to go from 0 to 2 pi. Let's go into here, let's put in 2 and then pi, and there you have it. Kind of a funky curve going on there. That is a Lissajous figure. And you can see here, for us it started at 0, 1. So this figure started drawing, I would imagine, at 0, 1 here. It then somehow it went to 2.9. So I guess it then drew all the way over to here to go to 2 at 0.9. And then it came to 1.2 and 0.7. That's around here somewhere, etc., as it drew it. So there you have it. Drawing, and oh, by the way, don't forget don't forget radian mode, of course. But there's parametric equations, including Lissajous figures.